Hi everyone. In this training, I will show you how to build recurrent neural network using long short-term memory technique for time series forecasting. Particularly, I will show you how to build an LSTM model to predict S&P 500 closing stock price from historical market data. The idea is to use past stock behaviors to predict future price. So for the data set, we are using the S&P 500 data set. And then here is just basically some of the library that we need to import to build our LSTM model and TensorFlow framework. So here, I start out by loading the S&P 500 data set and then convert the date column into a proper timestamp and then sort the row into a chronological order. This step is important because an LSTM learn from data in time series, not just like a through random shuffle or just shuffle in the data. And then after that, it's just basically basic data exploration. So we need to understand what is our data set. There are built-in Panda function that you can use to explore the data. For instance, you could do the dot shape to look at the dimension of a data set. In this case, is 1,259 row by 11 column. And then you look at the information of the data. You could here basically you can see the name of the column of features, right? That's the feature of the data and whether there are a null or missing data and the data type. And then the is no is just basically another way of looking at it. There is any missing data in the data set. But you could tell from here, right? But this is just another way of looking at it. Just sum it all up. So one thing that we need to understand in a data set is like what are the variable, the Y variable that we are wanting to predict, and then what are the X feature set, right? The feature set that we are feeding into a model. So in this case, you could see here, uh, the idea here is to predict future price, right? That's the stock close price. And there are a couple of feature data that we feed into. We could feed in like low stock open price, highest price of the day, low, and the volume. You could use all that. Also, you could do like feature engineering to like cyclical time as well to feed into a model. And then here is just basically an actual, just printing out a few rows of the data to give us some sense of like what are the data contain. Okay, next up is basically always best to prep a data, clean up data to prepare as a feature, input features and or prediction variable, right? So in this here is basically what I'm doing is just basically identifying what are my base features that I want to feed into the model. This in this case like open, high, low, close, and volume, right? And then here is just basically the good thing about with time-based data is that you can actually engineer the timestamp to like a day of the week. The reason why you want to do that is when you add like day of the week features using like sine and cosine, it's transformation. The model can learn the weekly pattern, the market pattern in a cyclical way. So there's an optional that you could do that here. And then here's just my target variable, what I'm trying to predict. So basically the stock close price. Okay, next up is basically splitting the data set, right? Splitting the data set here. So instead of splitting the data randomly, I split the data by time. Older data become the training set, and the newer data becomes the test set. That's better match for real forecasting scenario because the model only learned the past when predicting the future. And then next thing I do is basically, this section here is basically I fit the min-max scaler only on the training data, and then apply the same scaling to both training and test set. This avoid data leakage and keep the evaluation more realistic. And then here, what I'm doing is just basically create a window sequence function, a sliding window, and then I just basically call, I mean specify the window size, and call the create sequence function to basically create a sequence of data set to fit into the model. So the idea here is like the raw time series is converted into like a sliding window. Each input sequence contain like the previous 30 time step, and then the model learn to predict the next closing price from that data. And then here just basically just kind of it's good after you split your data, you want to do a basic check on the shape to make sure that the data is split correctly. And then this section is basically building the model using TensorFlow. So the network uses a stack LSTM layer with dropout in between. The LSTM layer help capture long-term time dependency, while dropping help reduce overfitting and randomly turn off some neuron during training. So basically what I'm creating, the first layer is 64 LSTM. And here I specify my input shape. So basically my input shape is 30 by 7. So basically I'm just like indexing my shape, right? So 30, and here is basically a 7. And then the second layer is basically 32 LSTM. And then my dense layers, this is the output layer. That's what I'll be like predicting, right? The actual output, just one neuron. And then if you want to see the model summary, just do a print model.summary, and it'll give you a summary of the model. Okay, next is basically training. So for training, before you can start training, it's good to understand for the model, what does it come with? Meaning, what are the tuning parameters that you can use to tune the model or train the model? In this case, I'm just tuning based on like learning rate, and I only training on 2 different learning rate, 2 different batch size, 2 different windowing size, then 2 training epoch. You could play around with this and change this parameter. But for this demonstration, this is what I use for the training. And then I also initialize the best value underscore loss to NumPy infinity value. So this is just for me to use in my early stop, right? So that way I the model stop training when its validation loss stop improving. And then this is basically just calling the model, compile the model that we create above, and then storing the training history. And then here I save the best model to basically load later on for the prediction. So I already trained the model. It took about 3 minutes and 46 seconds. I'm not going to run it again here. Okay, here is basically the evaluation. So after training, I reload the safe best model, make a prediction on the test data set, and do like an inverse scale the result back to the actual price value, and then evaluate the performance using like MAE, RSM, MAPE, to measure like mean average error, square error, and percentage error. So this is what I'm doing here. So loading the best model, feeding in the prediction price, prediction data set, doing a inverse scale to scale back the actual actual stock price, and then just basically capturing like mean absolute error, mean root mean square error, and then mean absolute percentage error, and then this is just the printout of the result. As you can see here, it's pretty good. The blue line is actual stock price, and then the orange line is a prediction price. You can see a little bit offset here just because we do our windowing. 30, our window was set to 30. So basically like it read in 30 past data before it could make a prediction. So that's why you see it's a little bit off, right? But they track pretty well, but sometimes they are a little bit off here, a little bit higher. So what does this actually mean here? So so the mean absolute error mean that in this case it's like a 3.37. It means that the model predicts prediction differ from the true closing stock price by $3.37. So that's not bad at all. And then the RSM suggests that some predictions have higher errors since RSM penalize bigger bigger misses that more strongly. As you can see here, it's right. Those are the bigger misses. And then the mean absolute percentage error mean that the model predict price are on average about $5.19 away from the actual stock price. So it's not too bad. And then here I just basically create a code just basically show the actual prediction, just like a one input sequence. So here I'm just creating one input sequence to feed into model to test the model and show the result. So as you can see here, for this input sequence, I'm pulling data set from 23 July 11. The actual close price was $188, and the prediction price was 183, and the absolute error as well is 4.19, so not bad at all. So this is actually how you use the code, right? There's a lot of way to fine tune this. You could explore that, to make the model better by adjusting all this tuning parameter here. So I hope you find this training very useful on how to build LSTM model for prediction.